Hi everyone, and welcome to the Science Hub, your one-stop shop for all things learning and growth. Like, subscribe, and share our videos to help us grow. Don't forget to check out our Facebook page at the Science Hub for more learning resources and community fun. So we want to continue with this question. On our previous video, we couldn't continue with this question because of technical issues, which is why we are going the traditional way today. As you can see, we're just shooting a video. So we were supposed to calculate the Q value, which we posted on our previous video. Now we need to find the kinetic energy of the alpha particle after decay. We are not just going to find the kinetic energy, but we are going to make use of the conservation laws of momentum and the conservation laws of energy to find this kinetic energy. So can you follow me closely and let's get right on to it. So the solution, the conservation of momentum is 0 is equals to my Vy minus m alpha v alpha. That is going to be our equation 1. And then the conservation of energy is Q is equals to 1 over 2 my Vy squared plus 1 over 2 m alpha v alpha squared. And this is going to be our equation 2. I hope you guys are following closely. So now I want us to take equation 1. And make Vy the subject. Equation 1 is 0 is equals to my Vy minus m alpha v alpha. So we are going to make m alpha v alpha equals to my Vy. So now we divide both sides by my. This is going to be Vy is equals to m alpha v alpha over my. So this is going to be our equation 3. Now we are going to infuse this equation 3 into this equation 2. So we are going to infuse equation 3 into equation 2. Remember, equation 2 says Q is equals to 1 over 2 my Vy squared plus 1 over 2 m alpha v alpha squared. So we are going to substitute m alpha v alpha over my. This we're substituting it into Vy. Where there is Vy and this equation, we'll put this. So now it's going to be Q is equals to, let me start with this section, 1 over 2 m alpha v alpha squared plus 1 over 2 my, open brackets, m alpha v alpha over my it's squared. I hope you're still following. Now, when we simplify this whole thing, it becomes, we want to simplify the bracket first. Q is equals to 1 over 2 m alpha v alpha squared plus 1 over 2 my, open bracket, m alpha squared v alpha squared all over my squared. So my is going to cancel the my that is here. So we will now remain with Q is equals to 1 over 2 m alpha, the section, v alpha squared plus 1 over 2 m alpha squared v alpha squared over my. So I'm going to make multiply 2 and my so that it remains as 2 my, and I'm also going to calculate this whole thing. I'm going to simplify the fractions rather. This then becomes Q is equal to m alpha v alpha squared over 2 plus m alpha squared v alpha squared over 2 my. So the common denominator here is 2 my. So I'll make this whole thing over 2 my. 2 into 2 my will remain with my multiplied by m alpha v alpha squared. Then this one plus 1 m alpha squared v alpha squared. So simplify, this thing becomes Q is equals to my m alpha v alpha squared plus m alpha squared v alpha squared all over 2 my. So I'm going to separate these two terms, this section and this section. I'm going to separate these two terms. So this now gives me Q is equals to my m alpha v alpha squared over 2 my plus m alpha squared v alpha squared over 2 my. Now I am going to collect like terms. Q is equals to, half is common here. Then m alpha is also common. V alpha squared is also common. This will now give me, if we remove half m alpha v alpha squared here, will remain with my over my plus, if we remove half m alpha v alpha squared in this section, will remain with m alpha over my. So Q is equals to 1 over 2 m alpha v alpha squared, my over my becomes 1 plus m alpha over my. We close our bracket. I hope I didn't leave anyone behind. If I simplify this inner bracket and find the common denominator, the denominator here is my. I am going to remain with, well, let's just do it on the side. If I simplify this bracket, this whole section, the common denominator here is my. So 1 over 1 into my, it gives me my times 1, it gives me my into my, it's 1 times m alpha, it's m alpha. So this would then give me my plus m alpha over m y. So I'm going to go back to my equation, and it's going to be q is equals to 1 over 2 m alpha v alpha squared, open bracket, my so half m alpha v alpha squared. This section is equal to the kinetic energy. Is it? So Q is going to be K alpha. Instead of having this, we're going to substitute it with this. K alpha, open brackets, my plus m alpha over my. So to find our kinetic energy, we are going to make K alpha the subject of the formula. This is our formula for calculating kinetic energy. So where Q is 4.87, the Q value, mega electron volts. My is 222 from our equation. M alpha is 4. So K alpha is equals to 4.87 mega electron volts times 222 over 222 plus 4. This will give us 4.78 mega electron volt. So now the question says I should comment. The question says find the kinetic energy of the alpha particle after the decay. Comment on the result that you get. So if you check, my Q value is 4.87 and my kinetic energy is 4.78. This shows that the alpha particle carries away most of the energy available in this decay. So my comment is the alpha particle Done.